So we have our next speaker in line. He's a Harry. So Harry is going to talk about framework and attacks. It's a basic topic related to cyber. Harry is from Adderma. He's working for Adderma. He's a product lead for detection and response. So I would like to hand over to Harry for its session. Over to you.
Thank you so much. And again, thank you for having me. Just share my screen and then we'll just do a quick check. Oh.
Sure.
Naturally right now that my Office decides to automatically update itself. Okay, can you see my screen?
Yep.
Brilliant.
Yeah.
Okay, so I'll do a slightly longer form introduction of myself now. Harry McLaren, I'm the product lead at Adderma for detection and response. My background is I started my cybersecurity and big data career now about almost 8 years ago when I started working in a security operations center. I worked as a security analyst, so I was essentially the end user of big data tools, first starting with tools like Logarithm and QRadar, and then moving on to Splunk as my organization helped transition this bank from one to another. I then started into my engineering journey as I started to become a trained and certified Splunk engineer, starting with the standard power user and admin certifications before moving on to architect, and then kind of finishing off with, I think the one I've got, which is the highest, is the SIEM replacement accreditation. Based on some of the other skills that I started to develop around cybersecurity consulting, and then where I go into tech, but also on the more business side around SOC processes, metrics, and the kind of strategic objectives that they're trying to achieve. Right now, my day-to-day job is working in Adderma and ensuring that what we build meets the requirements of our customers, and specifically around technologies or technologies. Community here in Scotland, and last but by no means least, I'm also as Tom is crossed for a third, and while my contributions on Answers and Slack aren't certainly even close to some of my peers in the organization, I am a user group leader as well up in Edinburgh, and I feel that that's where my biggest contribution is, as well as in my company. Feel free to follow me on Twitter, and if you'd like to reach out, I'll leave some of the contact details at the end. Super briefly about Adderma, we're a very large Splunk delivery partner in the UK. We've been a Splunk partner, I think, for 9 years, and we focus on consultancy and managed SOC. So this talk is going to start with us exploring a little bit about SOC capabilities. Now, SOC stands for Security Operations Center. I'll then later on be talking a little bit about some of the things that can go wrong when you're trying to run a SOC, some of the things that you seek to alleviate or improve upon. I'm going to then talk about 2 specific areas of improvement that I want to talk about, and talk about how the MITRE ATT&CK framework helps us with one of them, and how embracing DevOps practices and tooling like CI/CD, version control, configuration management helps with the other. So first and foremost, security operations have a number of key functions within them. These are but a few, but I'm going to talk you from right to left really briefly just to give you a flavor of some of the key things that a SOC typically does. Now, it does monitoring, so that is fundamentally enabling alerts to come out of security tooling or any other form of tooling that are security relevant, and monitoring those alerts perhaps night and day. Many SOCs are 24/7, including the ones I've worked in. Detection, this is about triaging and trying to understand, is what the alert says true? Is it a true positive or not? Have you actually detected threat activity, or is it likely actually maybe misconfiguration? That's obviously very common. The analysis is then when you go that next step and you try to then work out the scope of the problem. Is it an isolated small attack by some script kiddie, or is it an orchestrated nation state attack that's seeking to take out your entire business or steal your entire database? Once you reach a decision point of what to do, this is where response comes in. This can take many forms, but typically is about three key things: containment, eradication, and recovery. You want to contain the attack wherever it is. You want to ensure that you can then stop that attack and remove all traces of it from your environment and plug the hole however they got in. And then finally, how do you recover your systems? So ensuring that business as usual operations can return to the forefront. Two things that are other functions or supporting functions, if you will, is hunting. So everything I've just talked about in the monitoring, detection, and analysis space is when you know a certain type of threat activity could occur. It's what you knowns. You know it could occur. It's often about finding the unknown. You don't really environment, often within log event data, which of course we use Splunk for, to try and find indicators of compromise, indicators of threat activity that you can improve your hypothesis. The final and probably most modern is SOC technology, or automation orchestration. So this is all I just discussed, doing your best to automate it, make workflow really high level process that most SOCs go through, so that when I talk about improvements that we can make with MITRE ATT&CK, with Splunk, with DevOps tools, you understand where I'm referring. So this is a simplified process, but it starts with an understanding of a threat. Who could attack you? What could go wrong? How would they do it? This could be as simple as consuming, publicly available news or information, white papers, reports, and you might, for example, say that you are could be a target for ransomware, a very common attack type and something that obviously many organizations are facing. So with that decision made that you think that is a threat that your company could face, you would then develop a countermeasure. Some people might refer to this as a use case. You're trying to work out how can you prepare, detect and respond, and eventually recover from that attack if it happened. As you start to define the characteristics of your countermeasure, this is where you would potentially define a configuration change. So if we talk Splunk language, this is when you might identify a new or modified search that you might change to detect this type of threat. You would then go through a form of route to live, where you would deploy it into a warranty state or a monitoring state, where you're simply trying to ensure that this alert doesn't have a huge amount of false positives and that it's functioning as desired. It's not, for example, using all time as a modifier, or trying to, do a really weird join that's just bringing down your environment. You would then monitor that, usually for a fixed period of time. In most SOCs I've worked at, that's been 5 to 7 days. So as you monitor it, you might tune it. And then eventually there's going to be a decision point where you're comfortable with the quality of your configuration with your SPL, and you would then deploy that into a live state. At this point, your alerting is enabled, and the security operations team is then going to process those alerts and triage them and go through some of those functions that I mentioned earlier. So when they've brought context and triaged it, they're then going to come to a point. Now that's either going to be to close it, or it's going to be on to investigation and response. So with everything that I've just mentioned, what can go wrong? Now there are a whole bunch of things that can go wrong, and I'm going to focus on 3. The first is human error. We are all fallible. We all suffer from fatigue, from distraction. We cognitively get oppressed by context switching. There's a global pandemic, stress. All of these things might lead to human error. Other things that don't help are configurations that are overly complex. So you might have worked on one Splunk search ed that is configured in one way with a certain naming convention, and then you go and look at another and it's completely different. You could have parsing configuration that brings logs in one format and another system that does it in a totally different way. The more complex the system, the more likely a human's going to make a mistake. Disparate implementation types. So we are a multi-customer security operations provider. It means that we have got tens of customers' environments feeding into the same SOC. But as we all know, there's so many different ways to work with Splunk. It's one of its benefits. It also means that we have all these different environments. Things are called different things. Formats are different. It's very confusing. If you're an analyst, you can't be an expert in all of those different ways. So you've got to rely on documentation, which is often out of date, or you have to rely on other people's experience, which can sometimes be inaccurate. And then finally, manual checking and debugging. So if something's gone wrong and it's a manual check, or if you're trying to publish something and you've just got to remember to manually go through and test it, you then move on to this next one, and that is a failure to test. Testing is the kind of thing that in an operational function, it basically becomes a nice to have if you're not disciplined about it. If you're under time pressure, or if you're fighting off adversaries at scale, you're simply going to skip it. You're going to go, let's just get it in. Let's just do it. And I'm sure we've all had that kind of pressure placed on us where we've had to perhaps deliver something that wasn't as well tested as we hoped. Then you've got defects. Every time there is an issue, you've then got to do rework. So every defect is a threat because it's wasted effort. So what that means is you want the quality of work deployed into a live state to be very high the first time. And finally, we've got duplicate effort. If you've modeled ransomware as your threat, you don't want to have 20, 30, 40 different countermeasures, i.e. rules, potentially searches, that all look at the same thing, just in different ways. So, one search chooses to do its field extractions using Rex. One trusts in the data onboarding team and uses the field aliases within the common information model. Another one sets a threshold of 10. Another sets it at 20. So you suddenly end up with all this disparate work, all this duplicated effort to try and solve the same problem. So that's a threat. Again, wasted effort. It also means that you're not very efficient, because every time someone says, what about ransomware, you start from scratch as opposed to reusing valuable work that's been done in the past. And then finally, and this is very similar to the other one about disparate implementation types, is your configuration is customer or technology specific. We know that there are attempts within Splunk to try and simplify this with things like the common information model. But again, if it's not used in a disciplined way, you end up with sprawl, you end up with interpretations of tagging or interpretations of what aliases are relevant. And again, it means that you have to often duplicate your workload, and it makes the entire thing less efficient and less effective. So I mentioned we would have two objectives here. Well, our objectives are pretty straightforward. We want faster adaptation, right? By that, I mean we want to respond to threats as fast as possible. Threats change, so for our countermeasures must change. We must change. Threat actors are constantly pivoting into new technology types and bundling them in different ways. So we therefore must also constantly be looking at our rule sets. How you know that control is a really important part of a wider security strategy. Then we get to increase scalability. If I have a team of 10 people looking after a SOC, or indeed looking after a Splunk environment, I don't want to have to add a new person every time I get a new customer or a new team on board. Not limited. we do that, now I've come up with all sorts of things. Attack is going to be the focus here. Now, attack stands for adversarial tactics, techniques, and common knowledge. So fundamentally, it is a knowledge framework that tries to articulate threats in a clear way that enable you as defenders to understand how attackers are likely to come at you and ways in which you can defend against them. So at a top level, they provide you with an understanding of who the adversary might be. So they publish a list of known attackers. They articulate known mitigations, whether that be proactive preventative controls or your more detective controls that we might use in Splunk. They talk to the tactics, which are also referred to as the kill chain phase. So the tactics would be potentially steps an attacker would go through to get to their objectives at the end. And then finally, the techniques. What are the individual techniques that attackers likely string together to be successful? And again, it articulates the types of detection methods you could employ and the potential data sources that you could onboard to detect them. So already, working within this framework, we have a common language, we have a common understanding of hierarchy, how these data objects fit together, and this enables us over time to become a lot more effective in what we do because of this standardization. But let's explore a little bit more about attack. Now, attack on its surface is vast. It is a huge repository of, I think it's around 260 individual techniques and sub-techniques mapped to, I think it's 9 or 12 tactics. So I'm not going to leave this slide up for long. Oh, what happened? Oh, there we go. Back again. Do let me know if you can't see my screen. I'm not sure what happened there. So let's drill down. How would this work in real life? So as I mentioned, you've got the tactics across the top, and the tactics try to demonstrate steps an adversary is likely to go through. In this example, they first of all want to gain a foothold via initial access. They're then going to conduct discovery to try and work out what's available within the environment. And then they're going to do some form of data collection. And what techniques might they use? Well, to get an initial foothold, they might use a spear phishing link. So this email comes through, someone clicks on it, that's their initial access, tick, done. What's the next technique? Well, they might do a remote system discovery scan using there's a whole suite of tools out there, but they might use Nmap, they might use some common tools written in PowerShell for a Windows environment. There's all kinds of things they might use to discover what's in the environment. They've now detected a network drive. So in collection, they've now chosen to collect data from a shared network drive. So again, common language, common threat taxonomy, and I as a defender now know, well, that's the path the attacker might take. How do I either disrupt it, detect it, and so on? So let's look at one of the pages for one of these. So spear phishing link. This is some of the rich information that you get from the MITRE ATT&CK framework. You've got this nice, rich, full sentences, fully detailed technical explanation of what we mean. On the right-hand side, we've got a list of attributes that help us map this to that standard framework. So what tactic is it mapped to? Initial access. What platforms is it likely most relevant to? Obviously, many. What data sources might you be able to bring in to detect it? And then it links it to the contributors, when it was created, modified, etc. Further down on the page, you also get a list of mitigations and detections. So mitigations, how could you protect your users from spear phishing? You've got two things here. Restrict web-based content, i.e. An element of either block lists or allow lists. So you could say to your users, you are only allowed to visit certain allowed URLs, or you could try to restrict known bad ones. There are pros and cons for both. But obviously user training is probably the most valuable because it means that your end users can't be socially engineered. Then we've also got detection. So URL inspections mentioned, detonation chambers is mentioned. All of these things as an organization, and even as a knowledgeable, expert security organization like us, we still leverage this all the time because it enables us very quickly to get a really broad view of the tactic, the technique, and all the relevant information for us as a defender. So we first started using ATT&CK in about 2018. When we started to think about frameworks and taxonomies, we discovered the Magma use case framework, which is worth a read, and Sigma, which is an open source project that tries to basically take things like the Magma and the ATT&CK frameworks and put it into a version control system where you've got these YAML files which describe what you're trying to achieve all the way down to the rule itself. They then have a conversion engine which attempts to take that generic pseudocode for a detective control and then turn it into SPL, into ELK, into all kinds of different languages which can then be used. I would say the conversion software is a mixed bag, but the actual Sigma repository and framework that they've built is really impressive. So we started building use cases as code. We now refer to this as countermeasures as code or config as code. But we built a prototype, and then I internally managed to get that sponsored, and we've now built our countermeasures platform. So that looks a little bit like this. And you'll see that what we've essentially done from a high level is we've taken and mapped directly to the ATT&CK framework. We're not trying to reinvent the wheel, and it means that by aligning to this, what's essentially becoming an industry accepted and highly referred to framework, we're always speaking the same language as our customers and some of our partners. You'll notice Splunk has done something very similar by aligning. Top level, we've got the technique, countermeasures in the middle, and then rules at the bottom. So that is the specific SPL. And we're going to use an example from Sigma, but our system does look quite similar in that you end up with this brilliant plain text formatted description of the attack type, a description, relevant tags, the log sources, and then the detection itself. So by normalizing against all these fields, we start to become increasingly efficient. Now, this is also where I want to point out that Splunk is actually somewhat special for being able to work in this way. Now, so far, everything I've told you about isn't Splunk specific, but it turns out there are very important things you require to make this work at scale. One is schema on read, the ability to ask different questions to your data sources so that you can extract new fields, change parsing configuration, and so on at will when you need it. The second, although a lot more common, a web UI. You've got to be able to experiment and prototype new rules before you commit them into the system. One that you would think would have been embraced by all vendors, but sadly has not, is plain text configuration. Now, there are some very specific edge cases in Splunk where that's not the case, but the vast majority of Splunk's configuration is in plain text config files. This is an absolute must if you're looking to bring your configuration into a version control system. It has to be able to read it as machine data that can easily pass into clear text of some form so that it can version it. Doing that in a database, it's not going to work with most version control systems, certainly not ones that I'm aware of. Then finally, an open API. We don't communicate with Splunk in production over the web UI in most cases, except for prototyping and hunting. We do it over its API. Our system talks to its system and tells it what to do. And to have one that's fully enumerated and mostly documented is a big plus. So let's quickly just look at where we are from the effectiveness conversation. So we wanted faster adaptation. So how does ATT&CK help us here? Well, threat modeling. It gives us a huge list of threats to the organization, the techniques. It maps those techniques to potential adversaries. And it also articulates the possible data sources. It helps us by embracing the naming conventions in the relevant fields to write our configuration in the same standardized way. We didn't have to come up with an entirely new taxonomy or framework. We used the ATT&CK and added to it as we needed. And then finally, the mitigations and the knowledge enrichment provided by ATT&CK means that in our workflow tooling, and we use Phantom for that, we're able to then actually query directly into ATT&CK and say, could you please pull out additional context for this attack, please? We don't need to include it in the alert. We don't need to put it into Splunk. We can actually query they host a lot of their stuff on GitHub and pull down the JSON directly into Phantom for context. So as far as efficiency, and I'm going to talk you through this, but what we essentially built was the ability to do configuration management and at scale. So on the left-hand side, you're a SIEM engineer, and you've just prototyped a new rule, perhaps, or a change to a rule more specifically. You've decided that your rule's threshold of 10 failed logins within an hour is too high, and you want to take it down to 5. So you are on your Splunk Cloud Search Head, your production search head, where you have been experimenting with the SPL to make sure it's right before committing it into the system. So you've done some basic testing, and you now have your configuration. You then open the countermeasures management platform, which is underneath running on text. You merge the branch, which then runs to appear to be approved. We then move into the SOC application, and this is our self-service application. So what we can do is, with that approval, we can then custom directly a new will review it quickly, usually, and just go, yep, no problem. They'll click a button that says deploy, and over the RESTful API, the Splunk Cloud Search Head has its rule updated, it's loaded into live, and we now have a report that says new rule moved into warranty. Now, I know that looks like a lot of steps, but in practice, that could be 30, 60 seconds, especially if we've got automated deployment turned on. It's not a laborious process when you think about the actual improvements you get, because you're reducing human error. You are ensuring that it is a consistent and standardized configuration every time. And it means that if there are nuances within the customer environment, you can configure that into the deployment mechanism so that the SIEM engineer doesn't need to know about it. They write things to a standard. That standard occasionally needs to be modified for a specific customer, but the application does that for them because it understands the differences. And so that's just an example of how we, use what would be called, CI/CD, continuous integration, continuous deployment tooling, to achieve what we think is quite special and helps us a lot, especially in scaling. So thinking about what we said at the beginning about the capacities that you want and some of the challenges, what have we learned? Well, what we learned through this, and this was an experiment, we're not a DevOps shop, we didn't really have much of the way of a development function, we had to build it. First and foremost, we use Agile to build this, and we embraced Agile throughout the design of the environment to make sure that we're embracing it moving forward into operations. You must version control your configuration. It becomes super important if you make mistakes. It becomes incredibly important for audit. And when it's plain text, there's almost no reason not to. The ability to have everything there and a full change history is so important when it comes to working in production systems, especially security systems. Configuration management, you don't and shouldn't be giving your engineers SSH direct login access to your production servers. The question always has to be why. Why do they need direct access, and can you automate it? So we found that in our proof of concept we use Ansible, but we actually built a bit more of a bespoke tool for our needs. But that has the keys to the kingdom, and that orchestrates it always in the exact same way, in a secure way. We can key it at will with no issue. And what this led us to have is what we'd describe as a full route to live. We can prototype or develop configuration live in production. We can then put it into a warranty state while it's tested, and we ensure that it has no negative impacts to the overall system. And then we can enable it live in production. But all of this happens through the orchestration layer. There's no copying and pasting outside of that initial prototyping. So this also means that we have a huge amount of code reuse. So when we develop that rule against ransomware, because we've applied the standard taxonomy and the unit checks to make sure the SPL is relatively high quality, etc., it means that can now be used and viewed as a library of countermeasures that we can deploy for many customers. So what this means is that you have a SOC now that is built on empowerment, and because you've managed to make it as efficient as possible and effective as possible, you get to focus on the things that tend to lead to the best outcomes, and that's hunting. So when you have analysts that aren't constantly dealing with rework and dealing with human error and trying to find their SSH keys and all that, as you slim all that down, you ideally free up time to do hunting. Are thresholds still relevant? Lookups accurate? But make that iteration, constant adaptation is far better than a review every 6 to 9 months. Automate everything you can. Things are the most easy. Something going wrong, it will happen, it will always happen, but your ability to recover from that is often the key metric that a lot of businesses are moving to, something like the mean time to recover. So your ability to quickly roll back, because it's an version control system and you revert the commit and redeploy, that takes you 5 minutes, is far better than who changed what was it before, so on and so forth. So that is the talk. I really hope that I'm still actually live and not just talking to myself. I've got a bunch of resources. These are hyperlinks. Obviously, they won't work right now, but I'm happy to share these slides. Most of it, I'm sure you already know about, like Splunk and free training and everything else. And yeah, please do feel free to reach out. As I said, that's my email. You're welcome to reach out to me on Twitter, and I'm at Harry on the Splunk Slack community.
I don't have a question, but I just want to thank, because you just simplified it so clear for me, and there's a reason why you're on trust.
Yeah, indeed. So yeah, it is a good session. I just have one question. Like, what are the challenges that you face when you put that framework into live environment of SIEM? So what challenges that you face? Because that's what even we are planning, and if you give us a bit of idea of that, that would be more helpful.
Sure. So the biggest challenge, and I'd say surprise, was how long it takes to migrate existing content to that new system. The problem with standards and the problem with frameworks is you very quickly realize that some of the content you've developed before is not necessarily as high quality as you would hope. So, as I said, we've got tens of customers, we've got hundreds, if not thousands, of rules deployed into different production environments, and we had to look at all of them and say, which one's better, which one should we standardize, which one should we retire, which does that map to? So do not underestimate the migration time or cost, and make sure that you scale it in a way that as you basically turn off one and you turn on the other, you're not really turning it off, you're just setting it to not alert, and you monitor the output so that you can guarantee that you're getting the same, if not better, outcome from your deployed searches, from your deployed rules. We estimated a certain amount of time per customer. I think for some customers it's been quadruple that due to either the complexity of the SPL, but more frequently because we're actually using it as an improvement to change the SPL that was deployed in the first place. So we weren't particularly good at what I mentioned earlier, which was iteration, constant change, review, assurance of the quality of the controls. And now we're moving to that. There's been a bit of a shake up to say, well, what is currently deployed Is that still right? Is it high quality? If it's not, let's rewrite it now before we commit it into the new system. And of course, copying and pasting something across is a lot faster than querying, is that right? And is it still right? So yeah, do not underestimate the
explore much on that. I couldn't get you on that part.
Sure. So automation can help throughout all of your operational journey. In security operations, I would split it into two major ones. There is detection and there is response. Now, there are the operational people, the people that are essentially on the tools waiting for alerts and then telling the tool to take action. Automation is there in one respect to support them in what they do. So one example would be you have a security alert come through. It might dictate that you should go and identify the asset, i.e. what IP address, what device does that IP address belong to, and identify the user. So that user ID, who does that user belong? Now, you might have to go to different databases, spreadsheets, even send emails or IMs to people to find out that information as an analyst. Every time you copy and paste that IP address, every time you copy and paste that user ID, that is essentially a prime example of an automatable action. So one of the early value we saw in deploying automation technology was the computer will go and do those queries and send those messages and enrich the case or the ticket with all of that relevant information. Now, that's on the operations side, one example. The other is on the engineering side. So you've got operations, you've got engineering. Engineers are there to maintain and extend the platform. So automation in one example would be, as I mentioned earlier, if you're doing detection engineering, if you're designing and developing new rules, new SPL to detect threats, and you want to deploy that, well, say you develop one for, I've forgotten the code name, but this latest big vulnerability for Windows-based machines. Now, if I develop it and I've got 50 customers, do I want to have to log in 50 different search heads and copy and paste that, save it, remember the naming convention, click save, test it, check it's working, move on? No, because that is just a huge amount of repeated work. You'll get RSI from copying and pasting. So again, we use the orchestration layer to take care of that. It understands each customer's environment. It has the keys to log in. It knows what rules are live. And so you as a detection engineer can prototype your rule and recommend to every customer that it gets deployed immediately. Now, depending on the customer, some have auto deploy enabled, where they basically trust us enough that they're comfortable for us to deploy straight into live. Other customers want more control, want change windows that they then request and maintain. So if we were to click merge to all customers, some would get automatically deployed into warranty, and we're talking in seconds. Some would get a push notification saying there is a new rule and Adama has recommended that it gets deployed immediately. Do you approve? And they get to choose how long to wait or not for that. So, it takes from a task that might have taken 10 minutes times 50 to 10 minutes plus 5.
Okay, thank you, Harry.
No problem. Any other questions?
So hi Harry, this is Abhishek, and my question is more specific to the enterprise security content pack update. So how it helps with because there would be new rules getting added to the attack framework time and again. So how does it help from the Splunk point of view?
So in that particular use case, so where you've got enterprise security, they provide, just covering this for everyone, they provide content pack updates where you essentially can subscribe and download new countermeasures or new rules directly into enterprise security. In some respects, what we built is covering some of those features. So, we don't directly pull down content updates into any of our environments because we triage them and map them first to our system and then deploy them that way. But yeah, you're getting some of the benefits with that stream that we provide, but of course it's generic and you don't know if you want them all. Ours is a little bit more nuanced. In some respects, what we've got is a combination between enterprise security content updates and the Security Essentials app. You could kind of say that what we do is maybe about 50% of what those two apps do together, and then the orchestration and version control is the added bonuses of what we do.
Sure. Thanks, Harry. I'll connect to you offline also if I have any further questions.
Please, yeah, as I said, on Twitter, I'm on the Slack, feel free to reach out.
Hi, Nadeem here. I have one question. So, for example, there are people who are working on in and out on Splunk and managing the SIEM environment, and they want to move to cybersecurity or building the new SPL on the SIEM environment itself. So I see there is a huge gap between how they write SPL and how the SIEM works. So how we can fill that particular gap? There is a gap between how the security works and how the Splunk works. So how we can fill that, the bubble in between?
Yeah, so what you have is a challenge of all the different competencies required to do everything.
Correct.
You will get an individual who usually I would consider quite special, who can do everything from threat intelligence and canvassing the threat landscape to identify new threats, threat modeling, looking at those threats and working out the contextualization against your organization and how you might prevent or detect it. You've then got your platform, you've got your alerts. Now, it might be quite rare to find somebody with those skills. And so what you've got to decide is what are the competencies you pull together into a single role. For us, we have people that are specifically trained in threat intelligence and threat modeling. They are not Splunk experts, they are not security operations experts, but they are threat experts. They deliver briefs on new threats. Sometimes it's just recycled open source information, sometimes it's more bespoke. They deliver that to our detection engineers. Now, our detection engineers are a bit of a mix. They understand threats, but they're an expert on Splunk. So they are able to translate audit enabled will give us that. Do we have that in Splunk? No. Okay, request the configuration has changed. Yes, we do. Okay, brilliant. Then I'm going to construct a piece of well architected and well designed SPL to detect that activity. Because we also enforce a review pipeline, all of SPL must be reviewed by somebody else. First of all, it's reviewed by the system, which gives it really quite basic scoring on quality and tries to catch, simple mistakes where you're using, index equals all or, field extractions in line, those kind of things. We try and remove those. And then it goes to another engineer. So you try and get at least one other person to say, yep, that's a well-written piece of SPL. And then the analysts, they, in our environment, have a mixed experience. So some of them are have a higher level of expertise in Splunk for threat hunting, but most of them, their focus is on security operations and responding to the threats. So they're not necessarily deep dive Splunk experts. They can use it, but the experts are the platform and detection engineers. They're the ones that truly understand the weight, but they don't necessarily know how to respond to security incidents. And it's so you need a blended team in my experience, not just one or two highly educated people. You need a mixture of people because there's just so much to learn.
Yeah, that explains. That's fine. Thank you, Harry.